awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okey, dalam video kali ini kita akan tengok berkaitan dengan electric potential V and electric potential energy U. Okey, so jom kita mulakan dengan electric potential dulu. Alright, so electric potential is actually the work done in bringing positive. So for electric potential, it is actually defined as the work done in bringing positive test charge from infinity to that point in the electric field per unit test charge. Okay, so it is actually the work done in bringing positive test charge. So V is equal to W over Q naught, where Q naught is the test charge. Make sure in your calculation you must consider the negative sign of the negative charge. Okay, so electric potential is a scalar quantity, berbeza dengan electric field and electrostatic force. So ini adalah scalar quantity, so tidak perlu untuk awak lukis any direction. Okay, and the unit for electric potential is volt, which is V. And the second point about electric potential of a point in an electric field is defined as the potential energy per unit positive charge at that point in the electric field. So, apa dia relationship antara electric potential dengan electric potential energy? Okay, so V is equal to U over Q naught. So, kalau you tengok, equation V equal to W over Q is actually similar with V is equal to U over Q. Work unit dia adalah joule, U juga unit dia adalah joule. So, dia sebenarnya adalah benda yang sama. So, before we discuss about potential energy, so given that where the equation of potential energy is equal to U equal to KQ Q naught over R. So, kena ingat So, here when we substitute U in equation of electric potential, we actually can cancel Q naught. So, finally, you akan dapat satu lagi equation of electric potential where V is equal to KQ over R, di mana capital Q is a point charge. Boleh. Dan electric potential ini boleh jadi nilainya positif ataupun negatif. Ingat ya, dia adalah scalar quantity. So, when V is equal to positive and negative value, dia ada membawa satu maksud yang berbeza. Bukan direction, tetapi electric potential can be positive or negative based on the point charge. So, if the point charge is positive Q, kita akan dapat nilai V kita adalah positif. Apa maksudnya bila nilai V kita adalah positif? So, bila nilai V is positif, sebenarnya membawa maksud berkenaan dengan work, where work is done onto the system to bring the unit positive test charge from infinity to point P. So, dekat sini ramai juga yang rasa confused. So, jom kita lihat diagram yang diberikan di sini. Let's say we have a point charge positive Q as shown in the figure. And then here we have a point P. So, let's say I have a positive test charge which is small q here. So, ingat ya, bila kita ada dua charge yang sama, positive and positive, means that the test charge small q tadi akan repel to the right. Okay, so we can draw here that the electrostatic force on each charge should be opposite direction and each will repel one another. So look at here, what happened if we want to move this test charge to point P? So we actually need to do some work. Okay, so means that work is done onto the system by an external force, which means energy is required to move that test charge to point P. Kenapa? Sebab kita ada electrostatic force which is to the right, but we try to move that test charge to point P, means that we need an external force and work must be done onto the system in order to bring that test charge to point P. Boleh? Tapi bagaimana pula bila kita ada negative point charge, where the point charge is negative Q, the value of the electric potential V must be negative. So bila nilai V itu negatif, ia membawa maksud work is done by the system. Okay, the charge negative Q attracts the unit positive charge to the point P from infinity. Okay, so jom kita tengok gambar rajah ini. So kita ada negative point charge here and point P. So let's say I have a positive test charge at infinity and we want to bring that positive test charge to point P. Tapi disebabkan kita ada point charge kita negative and test charge kita positive, automatically both charges will attract one another. So bila kita lukis kita punya electrostatic force between these two charges, so the direction of F ke arah satu sama lain, iaitu attracted to each other. Okay, so if we want to move the test charge small q tadi ke arah point P, dia lebih senang because we have electrostatic force. So means that work is done by the system to move the test charge to point P. Apa maksud by the system? Means that work done by the electrostatic force itself. Okay? So remember ya, bila kita kira electric potential, bila dapat jawapan positif or negative, means that kita ada dua maksud yang tertentu, where V is positive when work is done onto the system, while V is negative when the work is done by the system. Boleh? Okey, sekarang kita akan cuba discuss example yang pertama berkenaan dengan electric potential. So look at here, we have 2 point charges. Kita ada Q1 and Q2 dan kita ada satu point P di mana kedudukan P dari Q1 adalah 4 meter and kedudukan P dari Q2 adalah 5 meter. Soalannya dekat sini, calculate the net electric potential at point P. Remember, electric potential is a scalar quantity. Jadi, bila scalar quantity, dia tak sama dengan electric field. First step, you perlu lukis direction at point P. Disebabkan V is a scalar quantity, please, no need to draw direction at point P. Tetapi, perkara kedua yang you perlu ingat untuk electric potential, bezanya dengan electric field dan electric force, dalam calculation awak, sekiranya ada point charge yang negatif, you must consider the negative sign of charge in your calculation. Boleh? Okey, kalau boleh, jom kita kira net electric potential at point P. So, kita ada 2 point charges, means that V at point P is equal to V1P, means that potential due to the first point charge V1P plus V2P. V2P means that electric potential at point P due to second charge. Okay, so kita masukkan dalam formula. Ingat lagi ke? Formula V is equal to KQ over R. So kita kena kira lah V1P KQ1 over R1P, di mana R1P adalah jarak antara point P dengan charge Q1. And V2P pula kita substitute KQ2 over R2P. R2P jarak antara point P dengan charge 2, di mana soalan dah bagi 5 meter. Okay, so now we can substitute all the values given, and remember that Q2 is negative charge. So dalam calculation jangan lupa untuk masukkan negative 6 microcoulomb as shown in the figure. And finally, the value of the net electric potential at point P is equal to negative 6,300 volt, where negative sign showing that 6,300 joule of work is done by the electric field, means that by the system, in bringing 1 coulomb of positive charge from infinity to the point A. Boleh. Okay, so let's say we want to calculate W. So we can use equation V equal to W over Q naught, and W is actually equal to V Q naught. So let's say kita ada satu test charge which is 1 coulomb, and kita dah kira tadi we want to bring that test charge to point P, and kita dah kira VP is equal to 6,300 volt. So kita boleh cakap W is equal to negative 6,300 joule. Okay, so negative means that work is done by the electric field, which is by the system, in order to bring the test charge from infinity to point P dalam case ini. Okay, so awak betulkan point A tu boleh tukar kepada point P. Okay, so next let's discuss about equipotential lines and surfaces. Apa maksud equipotential lines and surfaces ni? Alright, so the first point, an equipotential surface is a surface on which all points are at the same potential V. So maknanya when we have an equipotential surface, so at any points on that equipotential surface, nilai potential dia adalah sama. So as shown here, the green color showing you the equipotential lines ataupun surface. Okay, so at any point on the same equipotential surface, nilai potential dia mesti sama. Okay, second point, an equipotential surface mesti perpendicularly to the electric field at any point. Sebab itu daripada gambar raja you boleh lihat electric field lines must be perpendicular to the equipotential lines ataupun equipotential surface. Dan yang terakhir, poin yang ketiga yang paling penting, no work is done when a charge move from one point to another point on the same equipotential surface. Kejap lagi kita akan tengok ya, kenapa. Okay, kenapa no work is done? Sebab at any point on the same equipotential surface tadi, the electric potential dia adalah sama. Jadi dia tak ada potential difference between 2 point tadi. So no work is done in order to move the test charge from one point to another point on the same equipotential surface. Jom kita tengok contoh. So di sini saya ada dua diagram. Yang pertama adalah the diagram of the equipotential surface of an isolated charge, and the second diagram is the equipotential surface of a parallel metal plate. So sebelum kita discuss lebih lanjut, apa beza kedua-dua diagram ini? Diagram yang pertama, an isolated charge, you can see here that the electric field is ununiform ataupun non-uniform electric field. Okay, so for isolated charge, you boleh lihat dekat sini pada kawasan ditanda warna merah itu, electric fieldnya sebenarnya lebih kuat berbanding dengan kawasan yang saya tandakan dengan warna hijau. Sebab itu dia adalah non-uniform electric field. Boleh. Tapi untuk parallel metal plate, dianya berbeza. Okay, the electric field is uniform between the metal plate. Alright, so based on these two diagrams, you can see here that point A and point B are located on the same equipotential surface. Kedudukan A and B berada pada equipotential line yang sama. Jadi, disebabkan kedudukan A and B berada pada equipotential line or equipotential surface yang sama, means that electric potential at point A is equal to electric potential at point B. Boleh? But how about point C? So, point C, awak boleh lihat kedudukan point C tidak berada pada garisan yang sama seperti A dan B. Means that the electric potential at point C is not equal as VA and VB. Hanya VA dan VB sahaja yang sama. So, if we want to move a test charge from point A to point B, disebabkan electric potential at point A sama dengan electric potential at point B, so the work done to bring a test charge from A to B is actually can be calculated by this equation. Okay, kita nak kira WAB. Tapi disebabkan VA sama dengan VB, so VAB iaitu potential difference between point A and point B, kita boleh kira dengan guna equation V final minus V initial. So, bila kita nak kira the work done to bring a test charge from point A to point B, WAB is equal to Q0 VB minus VA. Kan tadi kita kata VB dan VA sama sebab point A dan point B berada pada equipotential lines yang sama. Therefore, WAB is equal to 0. That's why on the same equipotential lines or equipotential surface, no work is done in order to move a test charge from one point to another point. Boleh? Okey, sekarang kita nak fokus sikit berkenaan dengan potential difference. Apa itu potential difference? Alright, so based on this equation, we can see here that VAB adalah potential difference, perbezaan potential. V final minus V initial. So based on this equation, let's say we have point A and point B, di mana point A dengan point B ni tidak terletak pada equipotential surface yang sama. So, electric potential difference between these 2 points is defined as the work done in bringing a positive test charge from a point to another point in the electric field. Okay, so this is the definition. But the equation that related to the work done and the electric potential difference is actually equal to VB minus VA is equal to WAB over Q0. Di mana Q0 adalah magnitude of a test charge, where VA adalah electric potential at point A, dan kita perlu kira menggunakan equation KQ over R, while VB is electric potential at point B. Okay, so based on this equation, we can relate the potential difference between 2 points with the amount of work done in order to bring a positive test charge from one point to another point. Alright, so now let's try example 2. Okay, so here we have 1 point charge which is 5.4 nanocoulomb, and we have 2 points, point S dan juga point T. Okay, di mana point S terletak 6 cm from the point charge, and for point T we can calculate the distance between the point charge and point T. It is 10 cm. Okay, you boleh kira menggunakan theorem Pythagoras. So now let's try to answer question A. Calculate the electric potential difference between point S and T. So here we want to find delta V ST. Kita nak kira potential difference between point S dengan point T. Tapi sebelum kita kira Vs minus Vt, kita perlu kira dululah what is the electric potential at point S, Vs, and what is the electric potential at point T, Vt. Boleh? So here we can substitute V equal to KQ over R. So we can calculate Vs dan juga Vt. Where capital Q, you tengok dekat sini sebab kita hanya ada satu saja point charge. So capital Q is equal to 5.4 nanocoulomb. So after calculation, okay, kita akan dapat nilai untuk electric potential difference between point S and point T adalah 324 volt. Boleh? And then question B, calculate the work done in bringing a charge, which is a test charge of negative 1.5 nanocoulomb from point T to point S. So we want to bring a test charge from point T to point S. So now we can calculate the work done by using the equation of potential difference delta V is equal to W over Q naught. So as we have calculated before that delta V is equal to 324. So we can straightly substitute. Dan Q naught tadi, jangan lupa ya, the test charge is the negative charge. So dalam you punya calculation, jangan tinggalkan negative charge. Okay? So kita akan dapat W is equal to negative 4.86 times 10 power of negative 7 joule. Okay, sekarang kita akan sambung pula berkenaan dengan electric potential energy U. Okay, so electric potential energy is the electric potential energy U of a charge at a point in an electric field. So for example here, at point A, we can calculate UA by using equation of Q times VA. So ingat lagi ke relationship antara electric potential and electric potential energy. Sebelum ni kita dah lihat VA is equal to UA over Q. So in order to get equation of electric potential energy, we can try to rearrange that equation. So UA is equal to QVA, where small q is the test charge and capital Q is the point charge. So VA adalah electric potential at point A. So formula of VA is K times capital Q over R, where capital Q is point charge. So bila kita substitute dalam equation, kita akan dapat equation U selain daripada Q times the electric potential V, U juga equal to KQQ over R. Jadi dalam topik ini kita kena tahulah electric potential energy also a scalar quantity. So in order to answer question related to electric potential energy, no need to draw direction. Alright? And in your calculation, sama macam electric potential tadi, mesti consider negative sign untuk negative charge sekiranya terdapat dalam soalan. Okey, sekarang kita akan discuss dua perkara penting. Yang pertama adalah the change in electric potential energy delta U. Tapi sebelum kita discuss, I want to remind you that actually UAB, the electric potential energy U, is equal to WAB, di mana the difference between electric potential energy at point A and point B is equal to the work done to move or to bring a test charge Q from point A to point B. Ingat ya, UAB is the difference between electric potential energy at point A and point B, dan juga WAB pula adalah the work done to move a charge Q from point A to point B. And satu lagi equation UAB yang you perlu tahu, di mana we can calculate UAB by using equation Q times VAB. UAB adalah the change in electric potential energy delta U, ataupun UAB kita sebut juga sebagai the difference between electric potential energy at point A and point B. Kita juga boleh kira UAB menggunakan equation Q times VAB. Ingat lagi kan? VAB is the potential difference between point A and point B. So now let's try example number 3. So here we have one point charge, Q equal to 2 microcoulomb. And here we also have 2 points, A and B, where point A is 10 centimeter from the point charge and point B is 50 centimeter from the point charge. And given that we have a test charge 0.05 microcoulomb, okay, let's read the question. Calculate the electric potential energy at A and B. So sekiranya kita ada test charge Q at point A dan juga kita ada test charge Q berada pada point B. So kita boleh kira ke electric potential energy at point A and point B? Jawapannya boleh. Okay, so kita kira lah UA is equal to K times small q is the test charge, times capital Q over RA. Ingat ya, so formula dia nampak lebih kurang sama macam electrostatic force tetapi tidak sama. Okay, so ini adalah scalar quantity, so no need to draw any direction. Dan sekiranya ada charge yang ada negatif, so perlu masukkan negative sign dalam you punya calculation. So after calculation, kita akan dapatlah nilai electric potential energy at point A is equal to 9 times 10 power of negative 3 joule. Tapi bila test charge berada pada kedudukan at point B, so we can see here that electric potential energy at point B is equal to 1.8 times 10 power of negative 3 joule. Jadi semakin jauh point itu daripada test charge, so the electric potential energy at that point juga akan jadi semakin kecil lah. So kita boleh comparekan UB is smaller than UA. Okay, so now let's proceed to the next question. Find the change in electric potential energy between point A and point B. So we want to find UAB. So kita nak kira UAB, senang sajalah. Kita hanya tolakkan saja UB minus UA. So jadi dia kata between point A and point B. So kita ambil point B sebagai point yang terakhir. So UB minus UA. So final answer is equal to negative 7.2 times 10 power of negative 3 joule. So here we have negative sign. Remember, the negative sign means that the work done by the system, which is by the electric force, in order to move Q from point A to point B. So disebabkan kita punya test charge kita ni adalah positive test charge, jadi kalau kita nak gerakkan the test charge daripada point A pergi ke point B, tak susahlah sebab positif. So kita ada repellation between test charge and point charge. So the electrostatic force is to the right. So bila kita nak gerakkan the test charge from point A to point B, so work done by the system means that the work is done by the electric force. Okay? So sebab itu kita dapat jawapan kita adalah negatif. Alright, part yang seterusnya adalah berkaitan dengan electrical potential energy of a system of point charges. So the electric potential energy of the system of charges is the work done to bring all the charges from infinity to the points where the charges are placed. Okay, so kita akan nampak dekat sini, let's say we have 3 charges here, Q1, Q2 and Q3. So based on this diagram, we actually can calculate what is the electric potential energy of this system. Okay, but before that, remember, electric potential energy is a scalar quantity, so no need to draw direction ataupun resolve apa-apa. Okay, and the second point, so sama macam sebelum ni, you must consider the negative and positive sign of charge in your calculation. Jadi based on this diagram, in order to calculate the electric potential energy of the system, so U is equal to U between 1 and 2 plus U between charge 1 and charge 3 plus U between charge 2 and charge 3. So kita kena tambahkanlah semuanya. So equation U adalah KQ1 Q2 over R, tak ada squared ya. So kita selesaikan dan kita akan dapat jawapan sekiranya jawapan minta kita untuk kira electric potential energy of a system. Okey, saya rasa itu saja untuk video kali ini. So semoga kita jumpa lagi dalam video seterusnya. So assalamualaikum dan selamat sejahtera. Bye bye.